Good morning. Today we are going to see about the control system engineering. Control system engineering in signal signal modeling. In signal modeling, we are going to discuss about signal flow graph. Today we are going to see about signal flow graph diagram and how to construct the signal flow graph diagram and its purposes. First one, that is first signal flow graph reduction. So this is the main purpose of signal flow graph reduction is to find the transfer function. So by using block diagram reduction, so that is more complicated to find the reduction method. So we are going to use the signal flow graph reduction technique to simplify the block diagram reduction method. So the signal flow graph of a system can be reduced either by using the rules of a signal flow graph algebra by using Mason's gain formula. For signal flow graph reduction using the rules of a signal flow graph, right? So here we are going to see the step-by-step function of how to reduce the block diagram by using the signal flow graph reduction method. So here for signal flow graph reduction using the rules of signal flow graph, write equations at every node. First step, so we are going to write the equations at every node and then rearrange these equations to get the ratio of the output and input. So that is a ratio of the output to input. So here we are going to find the transfer function. The signal flow graph reduction by above method will be time consuming and tedious method. So S.J. Mason has developed simple procedure to determine the transfer function of the system represented as signal flow graph. He has developed a formula called by his name Mason's gain formula, which can be directly used to find the transfer function of the system. So Mason's gain formula. Mason's gain formula is used to determine the transfer function of the system from the signal flow graph of the system. Here we are applying the input as R of S. So R of S is input to the system and C of S, so that is the controlled output of the system. Now we can determine the transfer function using the formula that is ratio of the output of the system to the input of the system. So the transfer system can be calculated by using the formula that is T of S equal to C of S divided by R of S. Mason's gain formula states that overall gain of the system, so that is as follows: overall gain, so that is T equal to 1 by delta summation of K Pk del K. So this is the Mason's gain formula to determine the transfer function, where T of S is transfer function of the system and Pk, that is a forward path gain of kth forward path, and K, so there is K is number of forward path in the signal flow graph. Delta equal to, so how to determine the delta means by using the formula delta equal to 1 minus sum of individual loop gains plus sum of gains products of all possible combinations of two non-touching loops minus sum of gain products of all possible combinations of three non-touching loops, plus that is going on, and the delta K equal to delta for that part of the graph which is not touching kth forward path. So these are the parameters for determining the transfer function using the Mason's gain formula. And let us discuss one problem based on signal flow graph. So this problem is find the overall transfer function of the system whose signal flow graph is shown in the figure. So this is the given signal flow graph. So where R of S is given and C of S is the output of the system, and here we are having 8 nodes. So we are having 8 nodes. So now we are going to determine in step by step manner. So first one, we are going to check the forward path gains. So how many forward paths? So that is the starting node 1 to 8. So how many forward path is there? So let forward path gains be P1 and P2. Let us consider the forward path as P1 and P2. First one, that is first path that is crossing the nodes 1, 2, 3, 4, 5, 6, 7 and 8. And the second forward path, so that is 1, 2, 5, 6, 7, 8. So this is the second forward path, and we are calculating the gain of the forward path. So how to calculating the gain of the forward path means simply multiplying the nodes values. So for example, path 1 P1, so what are the node values means, that is multiplying 1 into G1 into G2 into G3 into G4 into G5 into 1. So that is the gain forward path 1, and the gain forward path 2, so that is 1 into G5 into G4 into G5 into 1. So this is the second forward path value, and next step we are going to find individual loop gain. So there is we are going to find how many loops in the function. So there is, we are obtaining that there is 3 individual loops. That individual loops gains can be calculated as P11, P21 and P31. So first one, that is loop 1. So loop 1, that is 3 and 4. So connecting the nodes 3 and 4. So that is the loop 1. Loop gain of the individual loop 1, that is P11 equal to minus G2 into H1, and the loop gain of individual loop 2, that is P21, which is equal to P21 equal to minus G2 G3 into H2, so which is connecting the nodes 3, 4 and 5. And next one, that is loop gain of individual loop 3, so that is P31, which is connecting the nodes 6 and 7, so that is known as equal to minus G5 into H3. So these are the individual loop gain we are calculating. We are having 3 individual loops. Next step, we are going to find the gain products of 2 non-touching loops. So there are 2 combinations of non-touching loops. Let us the gain products of 2 non-touching loops will be P12 and P22. So first combination of 2 non-touching loops, so there is first loop, that is 3 and 4, and next loop, that is 6 and 7. So these are the 2 loops which are non-touching loops, and another one is, that is second combination of 2 non-touching loops are 3, 4, 5 and 6 and 7. So these are the 2 different non-touching loops, and gain products of first combination of 2 non-touching loops, that is written as P12 equal to multiplying P11 and P31. So we are obtaining, there is G2, G5, H2 and H5. And next one, gain product of second combination of 2 non-touching loops, that is P22. So P22 is multiplying P21 and P31. Here we are obtaining, there is a G2, G3, G5 and H2 and H3. So these are all the gain product of second combination loops. And next one, we are going to calculate the value of delta and delta x. So how we are going to calculating the value of delta means, that is using the formula 1 minus P11 plus P21 plus P31. So there is a individual loop, and plus P12 plus P22. So which is the gain of the non-touching 2 non-touching loops. So here there is no combination for the 3 non-touching loops, and obtaining the values of delta value. So by calculating this value, we are obtaining the delta value, and delta 1 equal to 1. So why it is 1 means, since there is no part of graph which is not touching with the first forward path, and the part of the graph which is non-touching with the second forward path is shown in the figure. So that is known as the 3 and 4th loop. So here one non-touching loop is there, one non-touching loop in the second forward path. So we can calculating the delta 2 equal to 1 minus P21. So that is 1 plus G2 into H1. So finally we are going to determine the transfer function value. So the transfer function can be calculated by using Mason's gain formula. For the transfer function, T is given by 1 by delta summation of k pk into del k equal to 1 by delta p1 del 1 plus p2 del 2. So how we are determining the k values means, so the number of forward path is 2, so the k value is 2. So applying all the details, we can getting the final equation as G2 G4 G5 into G1 G3 plus G6 by G2 plus G6 H1 divided by 1 plus G2 H1 minus G2 G3 H2 plus G5 H3 minus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. So this is the final transfer function. So which is the transfer function, that is output divided by input, C of S divided by R of S. So this is the final transfer function we are obtaining. And finally there is some questions for signal flow graph. So what is signal flow graph, and what are the nodes in a signal flow graph, and what is the branch gain in a signal flow graph, and state Mason's gain formula, what is meant by forward path in signal flow graph, what is meant by a loop in a signal flow graph, and define non-touching loops with an example. And next one, differentiate between touching loops and non-touching loops. Write the overall transfer function expression using Mason's gain formula. What is the significance of signal flow graph in control system? List of the advantages of using signal flow graph over black diamond reduction. So these are the questions for practice. Hope you are understanding this video. Thank you.